Well, welcome to today's presentation, why multi-cloud matters and how to make the most out of your data regardless of where it is. I'm Bruno, Aziza, the head of data analytics at Google, and today I'm beyond excited to guide you through an action-packed and content-rich session of 30 minutes with two of the most experienced, innovative, and most fun practitioners I know in the world of data, AI, and analytics. On stage, on virtual stage with me today, I have Eric Best, who is the CEO and founder of SoundCommerce, and Nikhil Mishra, who is the Senior Director of Engineering at Verizon Media. Now, I want to make sure that you connect with these folks at the end of this presentation. I want to give you some background. Eric is a serial entrepreneur. He's a 20-year visionary with multiple exits and IPO. He's founded SoundCommerce a few years ago. He'll tell us more about his company in this session. But if you connect with him on LinkedIn, you need to know that he's a data expert, of course, but he's also a swimmer and aspiring DJ. So if you have a few things in common with him, don't forget to mention those things. Nikhil is a data leader that I'm sure you've heard a lot about before. His story's been covered multiple times. He and his team have built what's called Verizon Media's analytics monetization platform. This is a highly scalable system that stores over 200 petabytes of data and processes over 5 exabytes of data every month. So he knows what big data is like, and he'll take you through his transformation journey in the session today. All right, let's get started. Today, we really have 3 goals, 3 questions we want to make sure we cover. The first one is, why are we here? And what is multi-cloud and why does it matter? So we'll cover a little bit of that. Then we'll dive into the specifics of Eric's and Nikhil's journey. They'll give you a lot of the details on how they succeeded with their own journey. And then finally, I want to end with something that's very specific, actionable, that you can use at your company. We'll have the top 10 list of actions you can take as a result of today's session. Now, we want to hear from you in this session. And so if you like the session, if you don't like it, if you have questions, suggestions, you can interact with us through the chat, but you can also reach out to us on LinkedIn and Twitter and all the other social platforms that you like. This session is for you. So we'll start with this first problem here, which I'm sure you've experienced. We live in the world of data explosion. There's data everywhere, 175 zettabytes of data in the world by 2025. That's 21 zeros. And I'm sure you're finding this yourself. Where does this data come from? It comes from cat videos, for those in the consumer world, of course. But for us in the enterprise world, it comes from server logs. When you think about e-commerce, it comes from every part of the relationship users of websites have throughout the process, not just the transaction. So there's a lot of data. Even at home, if you have a device that is connected to the internet, it is connecting to the internet and collecting data. So we know there's a lot of data that's being produced. The issue, though, is when it comes to using this data, we're only able to actually analyze and work with 5% of the data that we produce. And so when you wonder why this happens, it's often because our business is very siloed. Your different divisions across your organization have access to different capabilities, different tools, different skill set, sometimes different appreciation of what the data is like. And when we look at the data and the way it is stored and used, sometimes we find that it's coming from many different places. It's stored in many different formats, sometimes many different levels of granularity. And when you think about the consequence for the average enterprise, it means that you're having to create multiple pipelines. You have to move data left and right. You got to create a lot of data copies, which is not highly secure, and sometimes takes a lot of time for people to get access to the data they need in order to make the decisions in the time frame that they need it. Now, why is this happening? You can see some of the answer here in Gartner's latest research in the cloud. 81% of companies using public clouds are actually using more than one provider. So my point here, this means that multi-cloud is the world we live in today. It will continue to be the world we live in. I mean, if you just simply take a look at your day, you're gravitating across applications, data, use cases that have different forces. And it is kind of natural that we would continue to live in a multi-cloud world. Now, when you think about what we're trying to do here at Google, if you read our mission here, which is about accelerating every organization's ability to digitally transform and reimagine their business through data-powered innovation. We wouldn't be saying this if we didn't believe that the complexity of your world is that your data is everywhere. It's going to be in the Google Cloud, and when it is, it's great. And when it's in a different cloud, then we're going to provide you with solutions that allow you to innovate with data regardless where it is. Now, if you followed a little bit of the news that's been going on with Google, we introduced Anthos, which is a platform for application modernization. It's really an open platform that lets you run your apps anywhere, simply with high flexibility and securely. And if you look at the data world, what we announced recently is a product called BigQuery Omni. Because when you think about the issues that you have with analyzing data, we need to make sure we provide you with this multi-cloud analytics solution where you can analyze data across all clouds without leaving the familiar interfaces that you love and work with on a daily basis. So with BigQuery Omni, if you haven't looked at it, take a look at it, because it's the place where you'll be able to analyze data wherever it is with a consistent interface and experience, so you can break through the silos that we talked about earlier. Our vision with BigQuery Omni is to give you one consistent control plane to access all your data. And like I said, if it's in the Google Cloud, it's great. But if it's not, then we're going to make sure that you have the solutions to analyze this data. If you think about it, your users don't really care where the data is stored, and you shouldn't have to do that. And that's why with BigQuery Omni, we bring the compute to your data. We don't ask you to move your data. If you're familiar with the Looker solution, as many of you are here in this audience, you know that this is very consistent with the way that Looker has been approaching this opportunity of multi-cloud. We're providing you with a great API-first approach to the world, a semantic model layer, and an in-database architecture allows you to get access in real time to data regardless where it is. And so we want to continue that commitment to you so you can make the decisions that you need regardless where the data is. Because we know this is the reality that you're in today and that you're going to continue living in. Now, there are a lot of customer stories we can talk about here. I'm sharing with you a sample of these stories, but today we've decided to drill down into two specific great stories. As I mentioned earlier, the story of SoundCommerce and Verizon. So in the rest of this session, we're going to invite Eric and Nikhil to kind of share their journey, and they'll come out with great best practices that you can use at your own company. So I want to thank them first for taking the time. And before they do that, if you have no time and you have to leave now, this session will be recorded. You could come back and share it with your own colleagues and partners inside the organization. Do these three things. Go and take a look at BigQuery Omni, read about it, and if you want to get started with BigQuery, there's an easy way to get started for free, so I'm putting the links there. Let's dive into Nikhil's story. Nikhil, as I said, is an amazing leader and knows a lot about big data and has built an amazing application across a journey that went from on-prem to multiple clouds. He's going to take us through what that took and how he succeeded. Nikhil, the floor is yours.
Thanks, Bruno. Everyone, this is Nikhil Mishra. I manage a couple of teams around monetization and analytics at Verizon Media. We'll just walk through some of the experiences I've had using Looker, BigQuery, and our on-prem Hadoop environment to build our analytics product, the problems we ran into, the problems as we saw it, and how we were able to work on it. So Verizon Media, as a lot of you might know, is a combination of brands here, that here as Yahoo, AOL, Huffington Post, TechCrunch, and a bunch of other brands that you interact with on a daily basis. Those are typical numbers that you would see, in terms of usage at Verizon Media. We see a pretty massive amount of activity on a day-to-day basis. Users come on our site to check their emails, to check stories and articles, to search, to read articles, and do a bunch of other activities that create tons of signals that we have. As you deal with this kind of volume and this kind of popular sites on the internet, the amount of signals that is generated and the variety of analysis that is done downstream is enormous. Now that poses its own challenge, and a lot of times what that results into is people try to solve the problems piecemeal, because that's how it is easy to solve. And what you'll see is, somebody coming up and saying they want to handle on-performance analysis, and they'll create a data mart which is siloed using some kind of architectural combinations, technology choices. there will be somebody else who will build their own siloed solution for their own analytics. And this thing will continue repeating throughout the enterprise until you realize that you created a complete web of analytic systems that is very, very hard to navigate and extremely difficult for end users to go and analyze. And this is no different for us. We were in pretty much a very similar situation, a lot of proliferation of analytic systems, variety of technologies, justifications on why solution A should be used or technology Y should be used. And that's what we decided to address with the architecture that we're going to talk about. Before we began, we laid out 3 fundamental things that needed in our next-gen architecture. We wanted a predictable, cheap, massively scalable ETL layer. And with the history of Yahoo, we already had that kind of problem. We had massive scale Hadoop environments and clusters that we could use to do our large scale ETL processing. With ETL, you have a predictable workload. You have a lot of flexibility as users, as engineers, to go and tweak around and do the best, do the best kind of changes you want to do to handle your specific analytics workload. Interactivity we define it as, you should be able to run your queries and get a response within seconds, not minutes. So it should be predictable at a scale. So we scan based on our earlier analysis. We realized that users have enormous appetite for asking questions on our large scale data. And we do frequently scan exabytes of data every month to do that analysis and get responses to our questions. We also wanted, another critical piece that we wanted is to solve our semantic layer. When you have your definitions, in places, your metrics and dimensions available in multiple places with similar sounding names, but different definitions, it creates a lot of problems. And what we wanted to do is, as part of this re-architecture, we wanted to solve that problem once and for all. We wanted the definition all to be in one place, defined once, and available via BI layer to do that analysis. It's important that the semantic layer is connected with the BI layer because that's what keeps it fresh. Because people are using the definition to solve their analytics needs and report building in real time. So you don't end up having a documentation of some definitions which goes outdated as people change their definitions in the BI tool. So in this case, we picked up Looker, which has this capabilities. You're going to build your dashboards on top of semantic layer using LookML, and all the definitions are all in one place. Regarding the database, we picked BigQuery. As you saw earlier, the biggest problems we wanted to solve was the scale problem. And when we started looking at some of the numbers in the Dremel paper on which BigQuery is based, we realized that that's something that we want to see. And the paper talked about the prototypes and the numbers that were published were run on tables and data sets with trillion plus rows, 1,200 plus fields. That's very similar to what we had in-house. The interactivity, as I mentioned, was a critical piece in our architectural clause. Scalability and elasticity was something that was super important as we need to scale more or increase concurrency. We just had to add additional slots or servers, and we are good. On the concurrency side, we obviously wanted a pretty high concurrency as well, which has been a consistent problem across all kind of databases we had been using, where it's very hard to have a degraded performance, not a complete downtime when the concurrency or the user demand goes up. And we came across a pretty nice independent prototype run by a company called AtScale from our former colleagues, and which gave a pretty good analysis of how BigQuery stacks up against the competitive solutions. And as you can see there, as the concurrency goes up, BigQuery is one of those databases which, in spite of operating at a significantly large scale, it gives a pretty nice scale as you go and bump up your concurrency. So with that combination of technology choices, we decided to alter our architecture a little bit. Our initial architecture was based completely on Hive, so the users would have a BI tool like Tableau on top of Hive, and Tableau provided a complementary capability of caching. And that enabled us to use Hive as our backend system. So as you can see, the data comes from the beacons, goes into a beacon servers, goes into a private Hadoop environment with large scale data storage and processing capabilities. And from there, we wanted to ship this data over to the Google Cloud environment. One of the first things that we want to do when you do that is to do some math around what data you're going to move around. And we did that, that math, and we realized that the amount of data that we would be sending could take up at its peak about 70 gigabits bandwidth. And we had to make some changes working with our network team to increase the bandwidth, and which allows for a smooth movement of data. Because the last thing you want by bringing in interactivity in your system is to delay the availability of data for your users. You don't want to do that. And BigQuery, with this architecture based on Borg and a petabit distributed network, provided us another capability to start hooking up or start exploring tools which don't necessarily are limited by the data engines or interactive caching layer on the BI tool. And that opened up the possibility for us to try Looker, which is something that we have been wanting to use because of its semantic definition capabilities. We brought in Looker into the mix, and we moved all the definitions of every single metric and dimension and attribute in Looker via this Looker. And as we did that, we also leveraged Looker APIs to share the semantic layers outside of this BI tool, which was, if you think of it, it's a pretty amazing capability to have in a BI tool. Here is a living definition of your metrics and dimensions that your analysts and power users are using on a day-to-day basis to do their analysis. And the same definition you can pass on to other systems, other analytics solutions that you may have in-house. And for our case, we had another web application built for analytics, and that needed to use a subset of metrics and dimensions that were defined here. We brought that in and shared this semantic layer, the definitions, using the Looker's API layer with that system. What that allowed us to do is completely eliminate the problem of different users coming and questioning the numbers now where the definitions were off by a little bit. And in this case, the users were seeing the data which is defined exactly in one place, being queried from exactly the same place. Chances of those numbers going off are highly unlikely. We also brought in Google Sheets and obviously the SQL interface for a lot of users who like using Sheets, which is pretty nifty capabilities that we have. And that pretty much became our solution. And as you do your analysis, we keep monitoring the usage, and as you can see, 70% of our queries, and we have millions of queries hitting the system every month, and 70% of them complete within 30 seconds. This is pretty cool. Gives you a good set of users. On the usage of BigQuery, as we put on this architecture, the number of users, the number of employees, our colleagues that are using the system is a pretty significant percent of our our overall company strength. Most of the people use this on a day-to-day basis for their analysis need. As I said, there are there are tons of queries. The users themselves submit more than 1 million queries a month, scanning more than an exabyte of data. And we don't necessarily take into account the system queries or any kind of ELT workloads that are running here, which completely changes the numbers when it comes to scale and concurrency for the system. We do streaming ingestion, 300 megabytes every second. It goes up to 4 gigabits in case of 10-pole events. It's pretty massive scale ingestion that we do over there. The warehouse is more than 100 petabyte, ingesting 50 terabytes a day, and that's the kind of scale at which we are operating, and has been working pretty well.
Oh, sorry, Nikhil, this is Eric. I was just going to interrupt for a minute. I know we had an opportunity to talk before the presentation just a little bit about the scale of this solution that you guys have implemented. And I'm just curious, looking at the numbers here, if there were specific kind of key takeaways for the audience related to the scalability of this solution that you learned late in the process. Like what were some of the unexpected scalability challenges?
we some of the stuffs that we that we learned along the way, and I mentioned this in the earlier slide as well. We did not as we started moving the data, we just assumed that we'd be able to move this data, and our network is ready to handle this kind of system. And something we learned very early on is as you start moving large volume of data between different machines, one of the things you cannot ignore is the network bandwidth. And that is something that we learned very early on in our cycle. And we did saturate our NACs pretty early in the game, and that was a good learning for us. The other interesting piece that we learned was around streaming. On the BigQuery side, with the new Vortex ingestion coming into play, the Vortex API for ingestion coming into play, a lot of those limitations are gone. But if you expect your real-time data that you're ingesting every second is pretty high in terms of, it keeps going into millions of events per second, you may want to talk to your BigQuery team, because there are some tweaks that need to be made in order for that to work pretty effectively. Other than that, from scaling's perspective, it's been pretty straightforward. From expanding the data size, BigQuery has been able to scale it pretty well, and it's been able to handle multiple petabytes of data expansions every month with pretty much no op. And the ingestion rate, the other interesting piece that you may want to talk to your BigQuery team is around load slots, which is another important factor when you're ingesting your data.
Mm-hmm.
That is limited to, for example, about a terabyte or so, and that may have an impact on how quickly you are able to ingest the data into BigQuery. So that is a key part. If your data availability time is important for you, it's critical for your users, you may want to talk to your BigQuery team about that. This is largely on the ingestion piece. I would say there are a few things that you need to take care of it. On the querying part, you'll be operating with the slots pretty much. You have different kinds of slots that you could use. My suggestion, if you're operating at a very large scale, is to go with the reserved slots, because when you're operating at a pretty large scale, it's highly unpredictable. What kind of queries that are going to be hitting the system, and you might end up spending unexpected amount of money during peaks. Instead of that, you could make a trade-off of reserving the slots and giving slightly slower performance, but have a predictable cost model instead of highly fluctuating model. So those are the things I would say. It's interesting learnings on that part. I think it's a fairly great question that you asked. It allowed me to reflect on some of the things we ran into and we were able to solve through.
The other thing I know we discussed is you of course have your own consumer-facing media application, but was there a particular department or internal sponsor or use case that sort of drove the impetus for this change in architecture?
It was. Let me say it was multiple multiple folks running into different problems, right? So we always have your horizontal divisions like sales, marketing, or editorial, who end up spawning across your organization structures to do their to do their analytics, and they are the ones who usually face the biggest barrier to using data when you build siloed databases, siloed interfaces. And typically, and it was no different for us, right? So people are solving for their specific needs around data, and as there are use cases that require you to spawn across those data silos, that's where the problems happen. And so those horizontal functions within the enterprise are the ones that that really want this kind of a solution to work. So let's move on, and this is the example of what we're talking about. This is the kind of roadmap we are dealing with. We already, with this architecture, we have been able to streamline 20+ systems and build it into one large-scale, massive, unified semantic layout system. The journey still continues. We have a goal for us, for some time over the next few quarters, to be able to give our users a single entry point, a single interface with all the definitions in one place, metrics and dimensions defined once, and being able to use it transparently, without any caveats around what are the filters or different changes in different systems that dealing with earlier. At a pretty high level, if you have to crystallize this learnings, now I would say when you begin solving your problem, make sure you pick your technology based on your big picture that you have in mind. You really don't want to pick up a technology that is going to solve a piece of your problem, no matter how convincing that argument might be. If it does not fit your bigger picture, no need to pick up that technology. The less tech stack, the less complicated technology stack you have, the less number of technologies you have for each layer, the better it is. Don't trade off interactivity for scale. You really don't have to think one versus the other. In probably it was true a few years ago, where if you were to have interactivity, you had to pull out the data from a large-scale system like Hadoop, which is not necessarily meant for interactive responses, and put it in a caching layer and try to do your analysis over there. That's no more true. Another very, very critical piece is you want a single unified semantic layer, which is tied to your BI tool. You want a living semantic layer, not a documentation. So you want a semantic layer which your users are hooking up to and doing their analysis. That is super critical. And as you start doing this, you will see yourself moving up the value chain instead of trying to solve the same problem over and over again. And that's going to add a lot of value to your enterprise as you go about doing that. So that's pretty much what I had to share and some of the learnings that we have had. And I believe this will give us a good mapping between what you do on your day-to-day basis in your individual work areas. And hopefully you're able to learn a few things from here and apply that to your work.
Well, Nikhil, thank you so much for this part of the session. And thank you, Eric, for interrupting right in the middle as well, because this is what we want to create, a conversation between you guys, the presenters, and also the audience. So if you're attending this, we want to hear from you. Make sure you use the chat, and of course, use any social platform you'd like to ask some of those questions. Now, Eric's got a fascinating story. As the CEO and founder of SoundCommerce, he's got a lot to share with you. So Eric, take it away.
Thanks, Bruno. And so just to introduce everyone to SoundCommerce, we are a data platform for retailers and consumer brands, founded by a group of Amazon veterans. And the purpose of our platform is to collect real-time data from virtually every system and data source that supports marketing and operations across a retailer or consumer brand. And there are three core concepts at the center of this platform and data model. We describe them as profitable growth, customer experience, and lifetime value. And really what we mean by that is an understanding of retail unit economics, the ability to track operational state and its impact on customer experience, and then the ability to combine those two concepts into a customer profile and a view of customer experience and customer value across systems and channels. We've built this platform on GCP after we evaluated some alternative cloud platforms. We're applying a functional programming approach and utilizing some very modern services, including Kubernetes, Kafka, and BigQuery. But the real multi-cloud story here relates to our customers. And you can see some of the logos laid out here on the slide, the companies that we serve. It's our goal to help these brands and retailers integrate with and act on data that resides and is flowing, frankly, all over the place. So at the center of the platform, we're bringing together data sources and orchestration targets that range from modern SaaS tools like Shopify or Salesforce or NetSuite, as well as cloud services like AWS Redshift or S3 or Azure SQL, and even legacy data sources like EDI and SFTP flat file data sources that would support things like warehouse operations, fulfillment, and the supply chain. And the core of our platform is this multi-cloud data graph that is prescriptively built for the retail industry and presents data in a way that it can easily be modeled and orchestrated in flexible ways. We need the ability to get that data from all over across multiple clouds, rationalize it, and orchestrate it anywhere. And the result of all of this work is, well, there's a variety of outputs of the platform. We support the ability to do direct query of the underlying data. We support the ability to create triggered workflows to push data into downstream systems, say Zendesk or HubSpot. But we also provide the ability to visualize and analyze the data through an embedded instance of Looker. And that's what you're seeing here on the screen. And in this case, we've pulled together a variety of data sources: Shopify, Returnly, Google Analytics, ShipStation, and NetSuite. And we're building this real-time profit and loss waterfall for an individual order and, in turn, an individual customer. And these margin insights that we provide through this Looker interface support decisions that range from inventory allocation and location optimization to shipping upgrades and downgrades, even ad spend allocation and the targeting of promotional offers and discounts. Here's another Looker embedded screenshot. This is a concept of order status in real time. So throughput and processing speed is super important in order to be able to act on real-time order status with awareness of a particular customer. In this case, our customers are prioritizing fulfillment based on new versus returning customer identity, according to customer loyalty club status, according to marginal profitability, and even customer lifetime value. And the key here is that our customers run a very unpredictable and heterogeneous ecosystem of software tools and data sources. In fact, some of our larger customers are running on-prem legacy systems that date back to the early 1990s, which I can barely remember. And given our team history in enterprise data integrations with EDI, with data feeds, and with traditional databases, we knew going in that a fixed schema point-to-point integration approach was not going to work for our customers. So what's going on behind the scenes? Well, if you think about a traditional approach to this enterprise integration problem, you start with ETL, or in the modern parlance, ELT, because the transformation is happening sort of at the last moment, if you will. And the problem is that you end up in this race condition where, as the number of nodes grows, as the number of data sources on the left and the number of orchestration endpoints on the right grow, keeping up with the evolution of those APIs and the changes to schema and the changes to format becomes unsustainable. You've got your IT department or your system integrator working constantly simply to maintain what's already been built. And so it becomes very difficult to try to go and add new data sources and support new use cases over time. And we talk about this at SoundCommerce as an n-squared problem. Every new node drives exponential complexity. So when you look at what's happening under the covers at SoundCommerce to address this problem, what's happening behind the scenes is that we are collecting raw data from these multi-cloud sources through a combination of source-specific and generic adapters. We don't worry necessarily about ascribing meaning to the data until we've parsed the messages into atomic data entities. And these could be something as simple as a zip code or a customer first name or last name. And then eventually, when we know a use case or an orchestration endpoint, we roll these individual data elements up into these unique models. And this is very much in keeping with the semantic modeling that Nikhil mentioned in the prior session and the strength of LookML. In this case, we're actually doing some of this semantic modeling even in advance of the data warehouse. And the importance of that is to be able to support flexible orchestration of the data to non-BI endpoints. So at the core of the platform is this semantic mapping and data modeling engine that supports multiple models and multiple ways of getting to the data and actioning on it. And I guess what's important about this then is that when we come back to this complex multi-source, multi-endpoint integration problem, we're reducing that n-squared complexity down to something that scales much more linearly in terms of engineering investment and IT investment. And as far as the takeaways go, we see multi-cloud as a very intentional strategy informed by practical realities. You will not have control over what your partner chooses to run. what some other department chooses to run or what your international subsidiary might be running. And while there are important benefits of multi-cloud diversification, it's important to maintain that flexibility in order to accommodate as many business needs and end user use cases as possible over time. And architecture matters, right? It's a function of selecting the right tools in the first place, but also thinking creatively about how to orchestrate data through the platform. So when it comes to do's and don'ts, I've got 6 of them here. And then Bruno, I know you're going to review these overall together with us in a minute. But the first one is just thinking about future-proofing. Yeah, we believe at SoundCommerce that it's important to remain agnostic in terms of cloud and data sources and endpoints. Again, you're not going to be able to predict the future, and so don't try. It's important to contemplate that change is inevitable, and so we're talking about planning for and architecting for dynamic and heterogeneous systems and data. When it comes to the nature of the end user and the use cases that we think about, there's this whole theme of consumerization of enterprise technology, and it's clear that business decision makers are becoming more data savvy over time. They're going to want transparency and control, and so the idea of some black box data model that is obscured is not useful if you're trying to validate the data and share insights and so on. There's a flexibility component here, which is that there will be inevitable new use cases and more data orchestration endpoints over time. And then I thought I had to mention security, although I didn't talk about it specifically in terms of the architecture of our platform, because we're dealing with shopper personally identifiable information, and in light of CCPA and GDPR and SOC 2 compliance, it's very important to make sure that the data model supports modern privacy and security concerns. And then my final comment on all of this is simply that we don't think about this data integration and validation problem as a project per se. It is a never-ending, ongoing process. And so it's best if you set expectations regarding that in advance with your team and with your customers, and also instrument for that ongoing iterative process that never ends, but hopefully out of that process comes continual improvement and support of your end users.
That is incredible, Eric. Thank you so much for sharing all that with us. In the next slide, what we're doing is we're trying to recap and give you your your top 10 actions, and it can really take away. I took a lot out of both of your guys' presentations. Of course, I love what you said about, change is the only constant, Eric, right? And you want to future-proof your environment. You got to just assume the multi-cloud environment is your reality, and it's always going to be like that. Nikhil, you talked to us about, architecting and solving for the short term, but not forgetting the big picture. So being able to think about these two things. You also talked about making sure that we don't think we have to trade off, I think you called trade-off scale versus interactivity. And we're no longer in a world where you have to make those choices. So, don't program yourself that you have to make the choice between these two dimensions. Overall, what I heard from both of you really is this idea of, and you brought it up multiple times, unification, right? I think you talk about a semantic layer, Nikhil, and then you talk about semantic mapping, Eric, that really took me to this idea. Like, we have a complex world, but it doesn't mean that you have to have a complex environment for it. And you have to aspire to have a unification layer, a simplification layer for a world that is going to be complex for many, many years. I want to thank you both for taking the time. I hope this is as helpful to the audience as this session was helpful to me. I took a lot from it. I hope that we can hear from the audience. Of course, the audience, if you liked it, let us know, so I can let my boss know, of course. But if you didn't like it, or if there are other things that you think we should be doing, make sure you leave that in the survey and the comments. We want to hear from you. We want to do the best job we can. This session, these types of sessions are for you. There are a few next steps you can take. The first one is, of course, if you want to take a look at the technical guidance on how to do multi-cloud, we have a paper for that. If you want to get started with BigQuery, of course, we've got a free way for you to do it. And of course, going back to the point early on in this presentation, if you want to get a taste of BigQuery Omni, make sure you get your name on the list so we can get to you. Again, I want to thank you both, Eric and Nikhil, for doing this. I hope you get a lot of inbound requests of people connecting with you to talk more about this. I hope this was a great service to the community, and we can't wait to hear from you. Thank you all, and we'll see you soon.